7.5 is going to be all about writing and graphing inequalities. An inequality compares two expressions that may or may not be equal to each other. It's very similar to an equation in algebra, but we're going to be using a couple of different symbols in between rather than the equal sign. In example 1, we're going to practice writing inequalities. If we were going to write this word sentence, a number c is less than -4, then what we're trying to remember is we're going to use the variable c, but whatever number we pick would have to be less than -4. So you can picture the number lines that we've talked about, and remember that everything to the left of a number would be less than, so keep that in mind. Left is going to be less than. So if we were to translate this, then c would be anything less than -4. And so we would write the number sentence or the inequality to look like this. And it says is less than. It doesn't say or equal to, so we don't put the line underneath here. And so what an inequality tells us is that c could be any number that's less than -4. It could be -5, it could be -100, it could be a decimal or a fraction, and it could be any number that's less than -4. Coming up soon, we'll actually start solving for these, but for right now we're just practicing writing them from these word sentences. This time we're trying to figure out what an inequality would look like if we were talking about a number k plus 5. And again, you can kind of do this like we did the equation building. So k plus 5 is sort of like one expression here. And then on the other side, rather than putting an equal sign, we're going to use is greater than or equal to. And so this time, the symbol that we're going to use is going to be that this side of the inequality, k plus 5, is greater than, so you would put that sign, or it says it could be equal to, so we use that one underneath it to show greater than or equal to, and then it says to 8, so 8 would go on the other side of the expression, or the inequality symbol, and basically this would be expression 2. So it's just like equations, like I mentioned earlier in the video, where you have two expressions on either side of the symbol, but instead of equal sign, it's going to be one of these other inequalities, less than or equal to, or less than or equal to. For letter C, it says 4 times the number q, and so remember again, that's going to be one part of our expression. So 4 times a number q can be written as 4q, and then it's going to be is at most, and you can look at the notes we wrote up above earlier what that means, but it says if a number is at most, then what we're dealing with is that this side of the expression, 4q, is going to have to be less than, or it could be equal to 16, but it can't be any more than 16. So at most means that whenever you multiply by the 4 by q, that whatever you get in order to make this sentence true would have to be equal to 16, or it would have to be less than that. So a solution of an inequality is very much like when we were dealing with equations. A solution was what made an equation true, and in an inequality, it's still the value that makes the inequality true. Now, this is going to look a little different than equations because true isn't going to mean balanced or equal to each other, but we'll be solving for them. But you do need to know, again, there are solutions to inequalities, and down here it's important to recognize that inequalities can have more than one correct solution, whereas equations could only have one solution that made the entire equation true. In example 2, we're going to be checking solutions, and the directions say, tell whether the given value is a solution of the inequality. And here's where your algebra skills are going to come in handy. So the inequality they want us to start with is x plus 1 is greater than 7. And right now, again, we're just checking the solutions to see if these would make it true or not. And so they want us to see if x equals 8. So just like we did in algebra, we're going to substitute 8 for x and then keep everything else the same. Plus 1 is greater than 7. And then we're going to notice here 8 plus 1 is 9. And then nothing changes here and nothing changes over on this side either. So we have to ask ourselves, is it true that 9 is greater than 7? And of course it is. So we would say that 8 is a solution to this inequality. For letter B, they want us to try the inequality 7 times y is less than 27, and they want us to see if y equals 4 makes this true. So again, we're going to keep this the same and simply substitute in 4 in the spot of the y, but we know it meant multiplication, so we need to put in parentheses or a dot, and see if it comes out to be less than 27. And 7 times 4 is 28, and the rest of this says less than 27, but since 28 is not less than 27, we say that is not true, or it's not a solution, and so we would finish this one off by saying 4 is not a solution here. And letter C says z divided by 3, and we really do have to remember that this means divided by, and they want to know if that is greater than or equal to 5 if z equals 15. So we're going to plug in the 15 instead of the z, but keep this as a divided by 3 and see if it ends up being greater than or equal to 5. And since 15 divided by 3 is 5 down here, and we wanted to see if it was greater than or equal to, remember this is the key, or equal to 5, and since they do come out to be equal to each other, then we would say that this, or z equals 5, is a solution. Oh, excuse me, z equals 15. Sorry, I just got that. So 15 is a solution in this case. Remember to make sure you're showing all the steps of the work in this one, just like we've been doing in the algebra all along, as you're deciding whether 3 is a solution of the inequality. So each time you're going to substitute 3 into here. So put it in for b, put it in for n, and put it in for x, and use 3 each time, but show the same steps that we just did on the example 2 work. The final thing we're going to be working on for this video is to graph inequalities, and the graph of an inequality shows all of the possible solutions of an inequality on a number line. So we'll be solving just like we did in example 2, but then we're going to put it on a number line, and we're going to use an open circle here on that number line if we want the number not to be a solution. So for instance, if t is less than 5, or if x is greater than 7, then we would use an open circle because it couldn't be 5 or couldn't be 7 in our example. But then we're going to use a closed circle like this, and that would mean that a number is a solution. So for instance, if we said q is less than or equal to 4, then q could be 4, so you'd put an open circle there on the dot, or it could be anything less than 4. We're going to do some practices with this in a second. We're also going to use arrows to graph these inequalities, and arrows pointing to the left or the right will show the graph continues in that direction. So for our last example today, we're going to graph an inequality and we're going to practice it, and they want us to graph g is greater than 2. So the first thing we have to do is we have to have a number line, and we've talked a lot this year about number lines. You can pick them up at any point. I'm going to encourage you to start using the point that's really close to this number, and if you have to solve for it in the future, then wait until you've solved to kind of figure it out. You could put 0 in the middle, that's fine too, but sometimes you end up going farther than you need to. So I'm going to go with 2 right there in the middle, and as long as I count by equal intervals, in both directions, I can go up as high as I want. So I'm just going to go at least 3 spots to the right. Then I'm going to go at least 3 spots on the left. But when I count backwards from 2, I go to 1, then to 0, and then remember after that you go to -1 and your number line starts over going to the left. And we have to ask ourselves, are we going to do an open circle or a closed circle? So it says G could be greater than 2. It doesn't say it could be 2. If it wanted that, you would have that little line under there for equals 2. So we use an open circle when we say that it is not a possible solution. So it's going to go right over this 2 here around the spot, but leaving it an open circle, not filling it in. And then you're going to use an arrow to show what other solutions are possible. So if G is greater than 2, that means that G can't be 2, but it could be 3, 4, 5, anything to the right of the number line. So you're going to draw a pretty thick line going to the right from this open circle. And then you're going to put an arrow at it to say it could be anything over this side. So even the numbers that aren't on the number line right now because of our space would work as a solution for this inequality. And we're going to try one more. We're going to try to graph h is less than or equal to 5. So again, you're going to make a number line, pick a middle point, and I'm going to stick 5 in there because it's something that I know for sure I'm going to have to put in there. And then I'm going to go at least 3 spots both directions. So 5, 6, 7, 8 in this direction. Going backwards, it's going to go from 5 to 4, 3, 2. I don't even have to worry about negative numbers. And again, you could keep going out if you wanted to in equal intervals here. But in this case, we're going to say if h is less than or equal to 5, then we have to ask ourselves open circle or closed circle. And if h is going to be less than, but it could also be 5, that means we're going to use a closed circle on the number 5 because it means I could start here. So h could be equal to 5, but then it could also be equal to anything that is less than 5. So that means it could be 4, it could be 3, it could be 2, it could be anything in this direction. So we draw that big thick line over here and then put your arrow saying it could be anything this direction, even that's not on the number line yet. You are going to need a separate number line for each of these problems. They don't have to be big, but again, you have to go at least a couple of numbers out on either direction of what you're graphing.